Hey everybody, we are going to talk about operations on complex numbers. Let's begin by talking about what a complex number is, and specifically the imaginary part. So if we have a square root of -1, before today, we technically couldn't do this unless you knew this somehow from the past. Square root of -1 is now defined as the imaginary number I. So this is going to allow us to take square roots of negative numbers. We couldn't do that before. We would just say it's not real. And so this is our imaginary number. A complex number, just so you know, it can be a mixture. So it could be a real part plus or minus an imaginary part. So it could be a number with both real and imaginary parts. But we're going to focus just on the number I for now. So by definition, this is a definition, square root of -1 is always referred to as I. And so something to mention here, because we're going to need it in our work, is think about it. What happens if you square this? If I square a square root, what's going to happen? Let's change colors here. So if I take the left side of my equal sign and then the right side and I square both sides, well, the right side is definitely just going to be I squared. But what happens on the left side? Well, I squared a square root, so it undoes the square root, and so I'm just left with -1. So this is also equally important as knowing what I is, knowing what I squared is. So anytime you see I squared, you can replace it with -1 because of the definition of I. We know that I, by definition, right here, is square root -1. So anytime you square that, you can just say -1. All right, that's going to come up in our work right now. So number 1 here, let's work with a real number. Square root of 25 is 5, and that's because 5 squared is 25. So just remembering what we know about that so we can move into imaginary numbers here. So letter B, square root of -9, well, we have to do a preliminary step, square root of 9 times square root of -1. First of all, notice that this is exactly square root of -9 if you put them back together. But we now know, by definition, what square root -1 is. So our first square root of 9, that part we know is 3. And now we just talked about this. Square root of -1, this part right here, is going to be I. And so our answer here is just 3I. So we have that square root of -9 is 3I. And here's why. So because if you square this, 3I squared will take you back to -9. And let's break it into 2 steps so you see it. 3 squared and I squared. So 3 squared, definitely we know that's 9. And I squared, we just talked about that back here. That was this part up here. We just talked about it. If we square I, we're going to get -1. So if I put those together, 9 times -1 is -9. Exactly where we started at the beginning of this problem. So that's how we're going to work through these types of questions at the beginning here, where we're going to separate a -1 from the real part of our number. So let's try the next one. Square root -27, so we're going to start by separating. Square root 27 times square root -1. So the square root -1, we know what that is. We know that's I. Now, that part's done. We just need to work on the square root 27. So square root 27 is not a perfect square, but we do know a perfect square that goes into 27. Think about it for a second. Hopefully you thought of it. It is 9. So 9 times 3 is 27. So if we break this down, we get square root of 9, which is 3. Square root of 3, we can't simplify that really. And then I. So instead of boxing it in like this, what I would recommend is putting the I in front of the radical, just so you don't accidentally think that the I is under the square root sign. It technically is not. It already represents its own square root. So if it helps you, in case you might, I'll show you off to the side, in case you might accidentally write it like this, I would recommend putting the I in the front because this is incorrect. So just rearrange it, put I in front of the radical, and that's our answer. Let's keep going. So now we're going to multiply. Let's go ahead and use the box method here, but if you can see it, you can just go right into distribution. We have one factor, and then the second factor. The first factor has one term in it. The second factor has 2 terms in it, so I'm going to go ahead and use the box method here. So if I distribute the 2i, I have 2 times 3, which is 6, and then I times I, which is I squared. And then if I distribute the 2i to the 2, let me just show you what I'm talking about. Distributing the 2i back here to the 2, we have 2 times 2, which is 4, and I by itself. And this is positive. I'm going to go ahead and put the plus sign since we're going to add these terms together. So I like to keep the signs with it so I know that I'm adding or subtracting. Now, I would call this my answer. However, anytime you ever see I squared, anytime you see I squared, always replace it with what we said it equals from before. I squared, we talked about this just a minute ago, is always going to be -1. So we will replace that, and then that will be our answer. So we have, inside our box is our answer. Let's take it out. We have 6 times -1, because that's what I squared equals, plus 4i. And let's make that look a tiny bit better, and I'll move it back up to the top here. This is -6 plus 4i. And that would be the answer. Now, this is standard form. I'm going to show you what's not standard form. If I were to write this as 4i minus 6, even though that's the same answer, technically we want to put the term with the imaginary part in the back, and that would be considered standard form. So that would be our final answer. Let's keep going. Let's do number 3 here. We are going to FOIL this out because we have 2 terms times 2 terms. It doesn't matter which one you put on the side of the box, or if you even use the box method at all, you can just use the FOIL method. So I'm going to do the box method here. We have 5i minus 3 times I plus 2. And then we're just multiplying row times column. So this first box is going to be 5 times I squared. Then going across, I have 2 times 5, which is 10, and then just I. Going down here, I have -3 times I, so I have -3i. And then in our last box, we have -3 times +2, which is -6. And so the nice thing about the box method is that the diagonals are like terms. And so we have, in a combination, we can combine in the middle there. So our box, let's just write it up above. We have 5i squared, a total of 7i, if you combine the like terms, minus 6. Now I'm not going to box this answer in because if you think about it, I'm missing a step. I needed to replace I squared. So remember, I squared is -1. So replace it, and when you replace it, make sure you use multiplication. Don't accidentally write something like this, 5 minus 1. You might think it's subtraction. So make sure you replace it with multiplication. So 5 times -1 plus 7i minus 6. And so we get a couple more steps, the one will be there, -5 plus 7i minus 6, excuse me. And then remember our standard form. We're going to leave the imaginary part in the back. Okay, so 7i is going to be back here, and then put the real parts together. We had a -5 and a -6 for a total of -11. And it was a positive 7i, so make sure you include that. So our answer is -11 plus 7i. And that was us multiplying complex numbers. Okay, we're going to stop here, but then pick up in the very next video with continuing this worksheet. We will multiply more complex numbers. We'll also add them and subtract them, and then in the video after that, we will divide them.